All right, so today we're looking at the Major 2025 paper. That's 9709 slash 11. So let's get started with it. And we're starting with question number 1, which says 6 sine theta is equal to 1 plus 2 over sine theta for values of theta between negative 180 degrees and 180 degrees. All right, so here we have 6 sine of theta being equal to 1 plus 2 over sine of theta, right? And we're going to multiply all the terms by sine theta. So that's going to be here times sine theta. 1 is multiplied by sine theta, and here by sine of theta. So whatever you do to the left side, you also do to the right side. So on the left side, we'll be having 6 sine squared theta being equal to 1 times sine theta is sine theta, and that's plus this 2 cancel. So we'll be saying plus 2. If we take everything that's on the right side to the left, that's going to be 6 sine squared theta minus sine theta minus 2 is equal to 0. All right. So we now have this nice quadratic which we can solve. All right. So I will take this here. All right. I'm going to have this view. I think it will work good. All right. I think this should be fine. All right. I hope you can see my calculator.
Yes, sir.
Yes, sir.
Okay, so 6, -1, and -2. And this gives us, I see 2/3 as one of the solutions, and the other one is -1/2. So we're saying that sine theta is equal to 2/3, and the other one is sine theta is equal to -1/2. These are the two possible values of theta we're getting. Right now, sine theta is equal to 2/3. I'll go to the quadrants here, and we know that sine is positive in this quadrant here and also in this quadrant. All right, so sine is positive in these two quadrants, and in each of the quadrants we'll be having a value of alpha, which I call the fundamental angle. So alpha in this particular case is arcsine of 2/3. All right. Now when we do arcsine of 2/3, all right, so shift sign of 2/3, just make sure you're in degrees. This is 41.8 degrees. So we know that here we've got 41.8 degrees. All right. So for the value of theta that we're going to get within the range here from -180 to 180 degrees, right? It means that we can have our first solution as being this, all right, which is 41.8 degrees, all right? The other solution that we get from here is here, this angle here, which is 180 minus 41.8. So if we say 180 minus ans, we get 138.2. So 138.2 degrees is another solution. Right, let's go to sine theta being equal to -1/2. We'll also have the quadrants here. Sine is negative in these two quadrants if we're using the cast method, right? So looking at the range of values from -180 to 180 degrees, we are going to say if this is alpha, remember alpha is the angle those lines make with the horizontal line. In this case, alpha would be arcsine of 1/2. And we know that arcsine of 1/2 is, well, 30 degrees, right? 30 degrees. So we're going to read, because if we read in an anti-clockwise direction, then the angles we will get are outside of will be outside of range, greater than 180, which won't be good for us. So we can go clockwise. So going clockwise also means the readings of our angles is going to be negative. So this one is negative alpha, which is minus 30 degrees, right? And the other angle is read clockwise again, all the way to touch this line. So that's more like 180 minus alpha, but negative, right? 180 minus 30 is 150, so it's negative 150 degrees. So what we have here are the four solutions. That's the answer to question number 1. I hope that's all right, guys. Any questions?
No, sir.
Okay, it seems everybody is okay. Let's move on to question number 2. Now we're on question number 2, and it says the equation of a curve is such that dy by dx is equal to that. The curve passes through the point A of coordinates 4 and negative 11 over 2. So find the gradient of the normal to the curve at the point A. All right, so if we're going to find the gradient of the normal to the curve, we first have to be able to find the gradient of the tangent. Okay, and for that, we know that x is equal to 4, right? So therefore, it's going to be dy by dx is equal to 4 of 2 times 4 minus 5 to the power of 3 minus 9x. Now x is 4 again, right? So we will put a 4 here to the power of a half. So that's basically, that's 8 minus, inside here, 8 minus 5, that's 3. 3 cubed is 27. 27 times 4. Okay, 27 times 4 is 108. So we have 108 minus 9 times 2, basically. So times 18. And we should get dy by dx to be 90 here. So 90 is the gradient of the tangent. So therefore, the gradient of the normal, remember the normal and the tangent are perpendicular to each other. So it's going to be the negative reciprocal. So negative 1 over 90 will be the answer here. So that's what we get on part A. All right, let's go on to part B. Part B says find the equation of the curve. All right, so to find the equation of the curve, when we have a derivative here, means we are doing the reverse of differentiation, which is integration. So essentially, we are saying the equation of the curve will be y is equal to the integral of, and now we are integrating this function here, all right, this function, which is 4 of 2x minus 5 to the power 3. Let me just write that down. So 4 of 2x minus 5 to the power of 3. And that's minus 9x to the power of a half with respect to x. I hope I've copied that correctly. Yes, that should be right. So that's what we're integrating to get the equation of the curve. So we're saying that y will be equal to, now integrating this will give us 4, open bracket, 2x minus 5 to the power of 3 plus 1, which is a 4. And that's over. Then here we take the 2 from inside here, and we multiply that by 4. So that's how we do it, all right? So I'm using the fact that if you're differentiating with respect to x, when you're integrating rather, if you're integrating ax plus b to the power of n, this gives you ax plus b to the power of n plus 1 over a of n plus 1 plus c. So that's essentially what I'm using right here. Right, so that's going to be minus, now integrating this, we know that a half plus 1 is, okay, I'll just have the 9x to the power of a half plus 1, which is 3 over 2. So 3 over 2, and that's divided by the 3 over 2 we got. So it's over 3 over 2. And that's going to be plus 0. So let's just simplify this, right? So we know here that the 4's will cancel. So we're left with a half So we have a half of 2x minus 5 raised to the power of 4, and that's going to be minus 9 divided by 3 over 2. It will give us 6. So 6x to the power of 3 over 2 plus c is what we will be having right here. Now, the equation of the curve will not be complete if we don't know what the value of c is. So if we can find a point that is on the curve, here we are given that on the curve there is the point A, which is 4 and negative 11. So we're going to substitute that. So we've been given that there's a point A with coordinates 4 and negative 11 over 2, right? That's what they say, right? 4 and negative 11 over 2. So we substitute these values, okay? X and Y. So that's going to be minus 11 over 2 is equal to a half of 2 times 4 minus 5 to the power of 4 minus 6 of 4 to the power of 3 over 2 plus c. All right, so that's minus 11 over 2 is equal to, on this part, we know that that's 8 minus 5, that's 3. So 3 to the power of 4. Okay, let me just do a calculation so that I can just use my calculator and it's fast. So I'll just say 4 and I'll store that into x, and I'll just say a half, 0.5 open bracket, 2 alpha x minus 5 close bracket to the power of 4, and that's minus 6x to the power of 3 over 2, which is like 1.5. Well, that gives me minus 15 over 2. All right, so that's minus 15 over 2, all right, plus c. All right, so if we're going to get the value of c, c will be equal to minus 11 over 2 plus 15 over 2, which is minus 11 plus 15, that's 4. 4 over 2 is 2. So therefore, the equation we want, okay, is y is equal to a half, okay, a half of 2x minus 5 all raised to the power of 4, and that's going to be minus 6x to the 3 over 2, right, and plus c, which is 2. So this here becomes the answer. Okay, so that's how we do it. I hope that's okay, guys.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Great. Let's move on now to question number 3. Now, question 3 is APGP. So basically that's series. All right. So the third term of a geometric progression is 18, and the sum of the first 3 terms is 26. It is given that the common ratio is negative. So in part A, find the 10th term of the progression and give your answer correct to 3 significant figures. Right, so we're going to make use of the information given. All right. Okay. Now, first they say the third term of a GP is 18. Now we know that the third term of a GP, we write that as AR squared, okay, is equal to 18. And now they say again, the sum of the first 3 terms is 26. The sum of the first 3 terms, right? The sum of the first 3 terms is like A AR plus AR squared. These are like the first 3 terms, right? This sum is 26. And they also say it is given that the common ratio is negative. So R is negative. So find the 10th term of the progression and all that. Now, if we're going to find the 10th term, it means that we have to figure out what A is and what R is. Okay. Now, I'm going to call this equation 1, and I'm going to call this equation 2. And if we take equation 1, and on equation 1, That's AR squared is equal to 18. All right. So we can actually make, say, A the subject, right? So A is technically 18 over R squared. Okay, let's look at equation 2. If we look at equation 2, we can see that actually on equation 2, since we have AR squared and AR squared here is 18, equation 2 can stand out to be A plus AR plus 18 is equal to 26. So I think this is a much better way to look at it. If we take 18 to the other side, on the left side, we are left with A plus AR, which is A of 1 plus R, actually. And 26 minus 18 would be what? I'm sure that'll give us 8. All right. Yes. So we can make use of that. All right. So essentially, we can say that here A is equal to 8 over 1 plus R. All right. So we have an expression here for A and another one for A, and they should both be equal to each other. So we can say here the 8 over R squared is equal to 8, this is 18 rather, 8 over 1 plus R. And we can cross multiply and try to come up with an equation in terms of R, right? So essentially that's going to be, if we cross multiply, that will give us 8R squared is equal to 18 of 1 plus R, which is, okay, let me just write it as it is. So that's going to give us 8R squared minus 18R minus 18 equal to 0. So we have this as an equation, right? So for this equation that we have, we want to solve for R, we can factor out 2. So that's like 4R squared minus 9R minus 9 is equal to 0. And we can attempt to factorize this. All right. So we have 4R squared. We can break it into 2R and 2R, or into 4R and R. Let's have 4R and R, and 3 and 3 for the products of 9. So this is 3 and this is 12. So if this is negative, then we're good. So this becomes positive. Right, so I factorized it then. Okay, so let's remove this. So it's 2 of 4R plus 3 of R minus 3. So essentially, the values of R will be getting, if we equate this factor to 0, we get R to be negative 3/4. And when you equate this to 0, we get R to be what? To be 3. Now remember, they told us that the common ratio R is negative. Okay, so we are going to reject the 3. So therefore, R is negative 3/4. Now, it's now easy for us to get A, all right? A, remember, from this particular equation is 18 over R squared. So we'll say 18 over negative 3/4 squared, okay, is what we'll be having. I'll just use my calculator for this. So that's 18 divided by 0.75 squared, and that is giving me 32. So A is 32 here. So for the question really wants us to find the 10th of the progression. Okay, the 10th term of the progression. And for that, we will just say 10th term is A, which is 32, of R, which is negative 3/4, to the power of 10, 10 minus 1, right? So to the power of 9. Remember, if you want to find any term, u sub R, it's AR to the n minus 1, basically. So what do we get from this? All right. That's 32 times negative 0.75 to the power of 9. And we get the answer to be negative 2.4 to negative 2.40 to 3SF. So negative 2.40. So this becomes the answer. All right. So that's how we do it. All right. I hope that's all good. I hope you got it, guys.
Yes, sir.
Sorry,
Yes,
why
sir.
did we 3 minus negative 3/4 instead of the 3? I missed that.
Oh, okay. All right. Let me help you with that. So the reason was because of this statement here where they say the common ratio is negative. So you see how we had gotten two results, one negative, one positive. So that's why we had to reject this and take the negative one. I hope you got that. Okay, nice. Let's move on then. Let's go to part B. Now on part B, it says, find the exact value of the sum to infinity of the progression, right? Now we know the formula for sum to infinity, right? Sum to infinity is a over 1 minus r. So in our particular case, we're just saying that sum to infinity is a, which we got to be 32, and that's going to be over 1 minus r, which is negative 3/4, right? Well, that's 32 divided by 1 plus 3/4. That's like 7 over 4, right? Which is 32 times 4 over 7. 32 times 4 is 128 over 7. So this is the answer. That's what we get, and that's how we do it. Right, let's move on now. We are now on question number 4. All right, so here it says the diagram shows the curve with equation y is equal to 5x to the 3 over 2 minus 20x, and the line with the equation y is equal to x minus 16. The x coordinates of the points of intersection of the curve and the line are 1 and 16. Find the area of the shaded region between the curve and the line. All right. Now, the good thing is that they are telling us what the x values for this point are. So this is 1. And at this point, we've got a 16, okay? That's what they say here, right? That's what they say. The x coordinates of the points of intersection of the curve and the line are 1 and 16, right? So they want us to find the area of the shaded region. And how are we going to do that? Okay. There are two things that we're gonna do. The first thing is we want to view these graphs as if they are in the first quadrant. Okay. Remember, if you have your graph in first quadrant terms, and this is, say, whatever, a and b, to find the area, you're simply saying the integral from a to b of your function with respect to x, and that gives you area. So we want to take it to be like it's in first quadrant, and we can easily do that just by kind of reflecting it in the line, in the x-axis, basically. So reflecting it in the y-axis means this graph will be negative of it. So we'll take it to be y is equal to negative 5x to the 3 over 2 plus 20x. And we'll also take this graph, negative of this graph. So we'll treat it as y is equal to minus x plus 16. So this is for us just to use our normal limits and treat it as if it was in the first quadrant. That won't change the value of your area. All right. So that means to find the shaded area. Okay, let me write it that way. So for the shaded area, area. We will find it by finding the area under the curve, and we subtract the area that is under the triangle. All right. I think you can see what I mean. Area that is enclosed by the curve. So the whole area enclosed by the curve, which is this whole area. And from it, we subtract the area under this triangle, basically. So that's what we'll be doing. All right. So let's work on that. For the area enclosed by the curve, it's simply the integral, right? From 1 up to 16. And we are making use of this equation. So basically that's minus 5x to the 3/2 plus 20x. All right, and that's with respect to x, minus the area enclosed by the line. That's the integral, again, from 1 up to 16. And we will use this. That's essentially minus x plus 16, and that's with respect to x. So let's do the integration, right? So integrating this, all right, we'll add 1 to 3/2. It becomes, well, 5/2. And we'll say 5 divided by 5/2. 5 times 2/5. Sorry, let's do it properly. The first one will be minus 5 x to the power of 3/2 plus 2, that's 5/2, and that's over 5/2. All right, and that's going to be plus. For 20x, integrating it gives us 10x squared, and that's 1 up to 16, and that's going to be minus. Integrating this gives us minus a half x squared plus 16x, and we have 1 up to 16 still. So we have here, dividing these should give us minus 2x to the 5/2 plus 10x squared, 1 up to 16 minus, this is still the minus a half x squared plus 16x. And that's 1 up to 16. Let's substitute now, starting with this piece. Substituting 16 will be minus 2 of 16 to the 5/2 plus 10 of 16 squared, and that's going to be minus, substituting 1 into it gives us minus 2 plus 10, and that's going to be minus. Now we're going to this piece, substituting 16, that's going to be minus a half of 16 of 16 squared plus 16 of 16, right? And that's going to be minus, let me put it maybe here, and that's going to be minus of minus a half plus 16. All right, and then we close bracket, so it continues to down there. All right, so we're just going to simplify this. It looks a little bit awkward, but I'm just going to use my calculator just for convenience. All right, so I'm going to store 16 in X, so shift store into X, and then I am going to substitute 16. Okay, so that's going to be 2 alpha X, and that's to the power of 5/2, which is like 2.5. That's minus, right? So I'll put a minus on it, and I'll have plus 10 alpha X squared. Okay, so that's like 512 that I'm getting. So minus 2x to the power of that Okay, so 512. Okay, that I got from that part. Let's substitute 1. Substituting 1, we saw that we get 8 here. So I'll just say minus 8. Let's go to the other piece. I'm substituting 16. I still got 16. So that's minus a half. And that's alpha x to the that's squared plus 16x. And that's alpha x. I get 128. So that's like minus, so 128. And substituting, that's going to be minus, substituting 1. That's just minus a half plus 16. And minus a half plus 16 is like 15.5, right? So 15.5. So let's just simplify this thing. We got, so 512 minus 8. And then that's minus 128 and plus 15.5. And we get 391.5 in the end. So 391.5 would be the final answer. So that's how we do it for this particular question. Yeah, you just need a bit of care when you're doing your calculations, and your calculator can come in handy. So, well, that should be all right. Anyways, any questions on this before we move on? Okay, doesn't seem anybody has a question. So let's move on to question number 5. On part A, it says find the first 3 terms in ascending powers of x in the expansion of each of the following expressions. So that's 2 minus px to the power 5. So key is first 3 terms. All right. So we're going to be making use of the MF19 formula, if you've forgotten it, for expanding binomially. All right. So that's going to be 2 to the power 5 plus 5 choose 1 of 2 to the power 4 of minus px plus 5 choose 2 of 2 to the power of 3 of minus px squared, basically. So that's what we're going to be simplifying, all right? So we know that 2 to the power 5 is 32. 5 choose 1 is 5. 2 to the power 4 is 16. 16 times 5 is 80. So we get minus 80 px for this one. All right. 5 choose 2 is 10. 10 times 2 cubed, that's like 10 times 8. We get 80 again. So this is going to be plus 80 p squared x squared. All right. It goes on and on, but they want the first 3 terms. So this is the answer to part 1. On part 2, they have 1 minus a half x.
Sorry, sir.
Okay, sorry, yes.
Why is the second one positive?
Do you mean
Yes, sir.
why it is positive? It's because the minus px the minus p and x are inside the bracket, right? So when we square a negative number, it becomes positive.
Oh,
So
yes,
that's
sir.
why you see that, right? So yeah. Let's go to the next one. We do the binomial expansion here. So that's 1 plus 4 of negative a half of x. Okay. Plus, well, essentially, this is like 4 choose 1, which is 4, right? So 4 choose 1 of negative a half of x plus 4 choose 2 of negative a half of x squared, and goes on and on and on and on. So here I'm using the fact that if you expand 1 plus x to the power of n, you get 1 plus n choose 1 of x plus n choose 2 of x squared and so on. That's what I'm using here. All right, so, well, this should give us 1, and 4 times minus a half is minus 2. So that's minus 2x. And 4 choose 2. I'm sure that should be 6, right? 6 times a quarter, 3 over 2. So plus 3 over 2 of x squared goes on and on, but we just want the first 3 terms. So I think we should be all right. So 1 minus 2x plus 3 over 2 of x squared. And that's it right there. I'm going to remove this because it's not part of the working. All right, let's go on to part B now, which says, given that the coefficient of x squared and the expansion of this is 93, find the possible values of the constant p. Okay, let's look at that. So we are expanding 2 minus px to the power of 5 of 1 minus a half of x to the power of 4. All right. So to excuse me, for in order, let me just drink a sip of water, sorry. Okay, so let's continue. Now, for us to get a term in x squared, all right, to get a term in x squared, okay, if you look at the expansion of 2 minus p to the power of 5, it got us this. Okay, let me just use these values. So I'll put it here. This is what we got from the expansion of 2 plus blah, blah, blah. So it goes on and on. And from the other expansion, okay, let me resize this so that everything can fit. Okay. And from the other one, we got 1 minus 2x plus 3 over 2 of x squared plus on and on and on, like that. So to get a term in x squared, that's going to happen when 32 multiplies the term in x squared here. So when it multiplies 3 over 2 of x squared, right? And when minus 80px multiplies this term, right? Minus 80px multiplies minus 2x. And when this guy multiplies 1, because at some point those products will come up, right? So plus 80 p squared x squared multiplies 1. So that's how we're going to get a term in x squared. All right, so this part, 8 times, okay, 16 times 3 will give us 48. Let me skip a line. Will give us 48x squared, and that's going to be plus 160 px squared, and that's going to be plus 80 p squared x squared. All right, so this is what we're having. That's the terms in x squared. So the coefficient is the one that's equal to 93. So I'll just take the constant parts. So for the coefficients, for 8 plus 160p plus 80p squared is equal to 93. And we're going to solve this. All right, so I think we need a bit of space because, yeah, so let's just make up space. Okay, let's see if this will help. So that's like 80 p squared plus 160p, and 48 minus 93 gives us negative 45. So we have minus 45 equal to 0. All of them are divisible by 5, aren't they? So that's going to be 5, 16p squared. 5 into this, that's going to be 3, 10 to 32p, and minus 9 equal to 0. All right, so that's going to be 5. Now we can try to factorize this. We have 16, so we can have 4p and 4p. And if we use 3 and 3, that's 12 and 12. That won't work. So let's use 9 and 1. So 1, 9, that's 4, 36, no, that one. So let's reverse them. So 9 and 1, 36 minus 4. This works when we have plus and minus here. All right, so the possible values of P then, when we equate this factor to 0, we get minus 9 over 4, and P comes out as a quarter. These are the two answers. These are the possible values of the constant P. So that's how we would work this out. Okay, I don't know. What do you think of this? Any questions? Okay, silence means that people got it, so it's all right. Let's move on then to question number 6. The equation of a curve is 2x squared minus kxy plus 2 equal to 0, and the equation of a line is y is equal to px plus 3, where k and p are constants. When k is 2 and p is 11, find the coordinates of the points of intersection of the curve and the line. All right, so when k is 2, it means that we have 2x squared minus 2xy plus 2 equal to 0. All right. And when P is 11, it means we have y is equal to 11x plus 3. All right. So we have these two equations, right? Equation 1 and equation 2. So we're going to substitute equation 2 into equation 1 to combine them to make up, one equation. So equation 1 will be now like 2x squared minus 2xy. For y, we put 11x plus 3, and that's going to be plus 2 equal to 0. So that's like, how much space have we got? I think we got good enough space, so I'll skip lines. So 2x squared minus 22x squared minus 6x plus 2 equal to 0. All right. So this should be all right. Let's write it as 2 minus, or maybe just as it is. So 2 minus 22 is minus 20 minus 6x plus 2 equal to 0. Let's factor out minus 2. So that will be having 10x squared plus 3x minus 1 equal to 0. Let's try to factorize this. If it is factorizable, if not, then we can use other means. 10, let's do 5x and 5x. Obviously, this is 1 and 1 because these are all the only factors of these. One of them has to be positive. If this is positive, this is 2x rather, because we can't have 5x and 5x. That's 25x. Sorry about that. 5x and 2x will give us 10x squared. So this should be better. 1 and 1 here. All right. So positive 2 and then negative. So minus 2 plus 5 is 3. So I think we are good. All right. So therefore, the possible values of x will be a fifth or negative a half. All right, so I will have this. I like to make a little table of values. All right, so when x has a value of a fifth and when x has a value of negative a half, then what is y? So we're going to make use of one of the equations. Let's use y is equal to 11x plus 3 excuse me. So y is equal to 11x plus 3. Is it? Yes, it is. All right, so a fifth is like 0.2. All right. I'll store that into x. So 11x plus 3 gives us 26/5. So one of the values is 26/5. And when x has a value of -0.5, that's -0.5. Shift store into x, back to the equation, -5/2. So -5/2. So according to the question, they say the coordinates right. So therefore, the coordinates, we don't need this, are a fifth and 26/5. Then -0.5 and -5/2. So these are your answers. That's what you'll be having right there. So that's how we answer 6 part A. Let's move on to part B. Now on part B, it says given instead that P is equal to 4, find the set of values of K for which the curve and the line do not intersect. All right, so let's look at that. Now, they say given instead, which means the conditions on part A are no longer valid. You need to really understand that. So since the values are not valid, so those values are no longer valid, and they say what P is now equal to 4, I will take the first equation. Okay, let me copy that. The first equation, this one, we will need it in our working. So here it is. And the second equation, we need it as well. It's y is equal to px plus 3. P is 4. Therefore, y is equal to 4x plus 3 is the second equation. So this is equation 1. This is equation 2. And we're going to what? Substitute as well. The two equations. So substitute equation 2 into equation 1, which means that we'll be having 2x squared minus kx of y, but y is 4x plus 3. So that's a 4x plus 3, all right, plus 2 equal to 0. Okay, so that's what we'll be having. We need to simplify this quadratic, right? How much space we got? We got good space. So let's go 2x squared minus 4kx squared minus 3kx plus 2 equal to 0. All right, for this 2, we can factor out x squared. So that means we'll be having 2 minus 4k of x squared minus 3k of x plus 2 equal to 0. Equal to 0. All right. Now, according to the question, find the set of values of k for which the curve and the line do not intersect. Okay. So we are saying curve and line do not intersect, which therefore means that b squared minus 4ac should be less than 0. And a, in our case, is 2 minus 4k, right? B is minus 3k, and c is 2. So, therefore, b squared, which is negative 3k, minus 4a, which is 2 minus 4k, and c, which is 2, right, should be less than 0. That means that 9k squared minus, actually plus, because this is 8, right? So minus 16 and plus 8 times 4, 32. K is less than 0. 9k squared plus 32k minus 16 is less than 0. All right. Factorizable. 3, 3, 1, 2. Let's do 9k and k. So this gives us that. And let's try 4 and 4. So 4k, 36. All right. So it has to be minus here and plus. Minus 4k plus 36 is 32. So I think it looks good. All right, so the critical values would be your values of k if this was an equation, which would be 4 over 9 and negative 4. All right. So what does that mean? If this was k less than, and the graph is like this is minus 4, this is 4 over 9. Less than 0 means negative. So we want the part of the graph that is negative, that is below the axis. This and this is values of k, which are between minus 4 and 4 over 9. So this here becomes the solution set. And that's the answer. Okay, just to put it where there is a little bit of space. This is the answer. These are the values of k, according to what they say. Find the set of values of k for which the curve is and line do not intersect. So for values of k between minus 4 and 4 over 9. All right, let's go on to question number 7. How many? Oh, we still got 8 and 9 and 10. So we still got a little bit more work to do. On question 7, it says the equation of a curve is y is equal to 4x squared plus 9 over x squared minus 8. So on part A, a point P is moving along the curve in such a way that its y coordinate is decreasing at 5 units per second. Find the rate at which the x coordinate of P is changing when x is equal to 2. Okay, so that's a very good question. We're going to start by finding dy by dx. We have been given y to be equal to 4x squared, and this can be written as 9x to the negative 2 and minus 8. And we're going to look for dy by dx. And when we find dy by dx, we get 8x, and that's minus 18 x to the minus 3, which is like 18 over x cubed. And when we differentiate a constant, we get 0. So here we get 8x minus 18 over x cubed for dy by dx. And when x is equal to 2, dy by dx, therefore, is going to be, okay, let me move this a little to the left so that we get more space. So dy by dx is going to be what? It's going to be 8 of 2 minus 18 over 2 cubed. That's like 16 minus 18 over 8, right? So 16 minus 18 over 8. Okay, so what does that give us? It's like, okay, let me just use my calculator here. So 16 minus 18 over 8 gives us, sorry, 55 over 4. So we get 55 over 4 as being dy by dx. I'm going to put it, sorry, down here. Okay, so now let's do the calculation of whatever they want, because they are saying here we should find the rate at which the x coordinate is changing. Basically, we're looking for dx by dt. The chain rule here will be dx by something times something by dt, and that something is dy. All right, so what is dx by dy? All right, dx by dy is the reciprocal of 55 over 4. So that's basically 4 over 55. And that's going to be times dy by dt. We've been told here that the y coordinate is decreasing at 5 units per second. So if it is a decrease, it's going to be minus 5 for dy by dt. So we're going to say times minus 5. All right, so we know that 5 goes into here, minus 1 times, and 5 goes into here, 11 times. So, well, the answer will come out as minus 4 over 11. So that's dx by dt. That's the rate at which p is changing when x is equal to 2. And that's going to be units per second, right? So I'll say here, units per second. Okay, so that's how we do it for this particular question, part A. Now going on to part B. Part B says we should find the coordinates of the stationary points of the curve and determine their nature. All right, so for stationary points, we know that dy by dx is equal to 0. All right, so I would say at the stationary points, dy by dx should be equal to 0. So this means, I think we had done dy by dx here somewhere, and we got this. So we're just going to make use of it down here. That's dy by dx, so 8x minus that. And we will equate this to 0. So that is like 18 over x cubed is equal to 8x. This is more like 8x to the power 4 is equal to 18. If we multiply both sides by x cubed, it's like x power 4 is equal to 18 over 8. And 18 over 8 is the same as 9 over 4, which means x is the fourth root of 9 over 4, right? Let's put it this way. Maybe that can be a much better way to do it. We can say here that x squared is equal to plus or minus the square root of 9 over 4, right? Which would give us plus or minus x squared being equal to plus or minus 3 over 2, right? But we're going to take the real value. So basically x squared is equal to positive 3 over 2. Now to get x, it will be plus or minus the square root of 3 over 2. So we can also do it this way, which I think is fine. So we're getting plus or minus the square root of 3 over 2 as the values of x. So what do they say? They say coordinates, right? Coordinates. So I'm going to have a little table here, which I prefer to do. And I'll say here, if x has these values, right? X and y, x has value negative root 3 over 2 and positive root 3 over 2. All right, and we have to substitute that into one of the equations. Let's use the original equation actually. So I'm going to take the original equation, which is this one here, and we're just going to place it down here so that we can substitute. So this is the original equation, which we're going to use to get the corresponding y values. All right. So I'm going to have here, all right, my calculator, and I'll have negative of square root of 3 over 2, shift store into x. So 4 over x squared plus 9 over x squared minus 8, and that gives us 4. So when x is minus root 3 over 2, the corresponding y value is 4. I will also have root 3 over 2, right? So root of 3 over 2, shift and store into x. Bring back the equation we had, press equals. I'm still getting 4. So we get another 4. So therefore, the coordinates are negative root 3 over 2 and 4. Wait a minute. Okay. And positive root 3 over 2 and 4. So these are the coordinates. Okay. And they say, and determine their nature. Determine their nature. So to determine the nature of the stationary points, we will find d squared y by dx squared. Remember, dy by dx was that. Okay, this was dy by dx that we had. Copy. Okay, let me place it here. Okay, so we have dy by dx already. This is what we had as dy by dx. I don't think I copied it well. This was dy by dx. Can also be written as 8x minus 18, x to the minus 3. All right. So for the second derivative, that's going to be 8. And here, that's going to be negative 18 times negative 3, which should be 54. So that's plus 54. And that's x to the minus 3 minus 1, that's x to the minus 4. So that's over x to the 4. That's what we'll be having. All right, so all right, or let's put it this way. The point negative root 3 over 2 and 4, we need to figure out what d squared y by dx squared is. And also at the point root 3 over 2 and 4, d squared y by dx squared is what? Okay. So in my calculator, I already had root 3 over 2 stored. All right, let me write that properly because it's a root 3 over 2. The square root is affecting everything. All right, so let me write that the right way. So it's a big square root, and this is negative. And here, a big square root affecting everything, top and bottom. All right, so I need to fix that. Root 3 over 2. And this one as well is the square root of 3 over 2. All right, so I think this now stands good. Okay, so I already have root 3 over 2 stored. So it's dy by dx is 8 plus 54. That's over x to the power of 4. So that gives us 32 here. So this is 32, which is a positive value. All right, positive value. Let me put it this way. It's greater than 0. Therefore, if it's that, then it means that it's a minimum point, right? All right. And then for the other one, negative root 3 over 2, shift store into x and bring back the dy by dx. And we get, again, 32. I'm getting the same. Yeah, we should expect to get the same because of this x power 4 makes everything positive. It's also greater than 0, so it's also a minimum. Okay, so according to the question, they say find the coordinates of the stationary points and determine their nature. They are both minimums. So that's what we will be having there. So I hope it's all right. That's what we do for this particular questions. Any questions, guys?
Sorry, so I just have a general question.
Yeah.
Since they have minimum point and similar coordinates, does it mean like the curves mirror each other?
You mean the points, like the
on
way
a
they are,
yeah,
like do they mirror each other since they, yeah, it looks like so. What type of graph is this? Let me check on what it is. Well, it's that type of graph. It's a curve. So yeah, it could be because if you look at the x coordinates, this is positive because the y coordinates are the same. All right. But the x coordinates, one is negative, one is positive. So it could be that they mirror each other. One, most likely one on the left and one on the right, but on the same horizontal. So it's possible that that is that way. And it's possible to have curves where it could be that this has multiple turning points. I don't really, we're not going to get into the shape of the graph, but yeah, it's possible that we might have something that is like that. And the turning point here, maybe, and the turning point here, but there are minimums. So maybe there'll be minimums, but one on the left side and the other one on the right side of the y-axis, but on the same, sharing the same y value. So kind of like that. That's kind of like how the shape of the graph could be, though the points will be minimums. So yeah, that's how it is. Okay, I hope you answered. Okay, thank you. Let's move on to question number 8. Here it is. Okay, it's a circles, coordinate geometry of circles, I think, type question. This circle with equation x squared plus y squared minus 6x plus 10y minus 27 equal to 0 intersects the line x is equal to -2 at the points P and Q. Find the area of the triangle formed by the tangents to the circle at P and Q and the line x is equal to -2. Okay, quite an interesting question it is. Um, we're going to start by, obviously, we will need to know what the center of the circle is. So I'll take the equation x squared plus y squared minus 6x plus 10y minus 27 equal to 0. And I'm going to complete the squares. So we'll be having x squared minus 6x regrouping plus y squared plus 10y equals to 27. So that's going to be x minus 3 squared plus y plus 5 squared. For this, we'll say minus 3 squared, and for this, we'll say minus 5 squared equals to 27. All right, so we will end up having x minus 3 squared plus y plus 5 squared is equal to, and here we'll be having 27 plus the 3 squared, which is 9, and 5 squared, which is 25, so 61. So it's all equal to 61. All right, so therefore the center of the circle, okay, we have it now to be 3 and -5. So that's what we have right here. Okay, so let's highlight that because we obviously will need that value at some point. And they say that this circle intersects the line x equals to -2 at the points P and Q. Let's find those points P and Q. Right, so we're saying here when x is equal to -2, what will we be having? We'll be having, I'll just take this, would be easier to work with. All right, this form of the equation. So when x is -2, it will be -2 minus 3 squared plus y plus 5 squared is equal to 61. All right, so here we've got 5 squared, that's like 25. So we're left with y plus 5 squared is equal to 61 minus 25. So y plus 5 squared, 61 minus 25, that should be 36. So y plus 5 is equal to plus or minus 6 if we square root both sides. So y is equal to minus 5 plus or minus 6. So the possible values of y are minus 5 minus 6, which is minus 11, minus 5 plus 6, which is 1. So we now have the values of y. How much space we got? Oh, we got good enough space. So these are the y values for P and for Q. They don't tell us which one is P and which one is Q, which means, well, it might not really matter what we are, where those points are. So we can try to make a sketch of the situation here. I'm going to draw a circle, right? And the circle has a center somewhere. The center is 3 and negative 5. Okay, so that's what we got. Then we've got the line x equals to negative 2. All right, so if this is at 3, if this is an x coordinate of 3, we can have that line maybe somewhere down here. Okay, so something like this. And we've got our 2 points on here, the point P and Q, right? So let's just say this is P, and let's just say this is the point Q, all right? And we're going to say that the point P would be the point. Remember, the x coordinate is negative 2, so this could be the point negative 2, negative 11, and this is negative 2 and 1. So basically, that's what we have. That's the kind of situation we have. Now, what does the question say? The question says we should find the area of the triangle formed by the tangents at P and Q and the line x equals to negative 2. All right, so the tangents would be like this. Okay, this can be the first tangent at Q. All right, making a sketch really makes things clear. You can really see where things are going. So I prefer making sketches whenever I solve problems like these. So you see, so the triangle, I think you can see a triangle coming out. This is the triangle here, whose area they say we should find. Okay, so I think it's all right. All right, so in order for us to find the area of this triangle, that's what they want, right? Find the area of the triangle formed. We might need to find the point of intersection of the two tangents. All right. And how are we going to find this? Geometrically, I think you can see that this point is well in line, okay, with this point horizontally, which means they share the same y coordinate. So for this point, the x coordinate, we don't know, I'll call it A, but the y coordinate is obviously going to be a minus 5. Geometrically, that's how it is, because we know that if you draw two tangents, right, on the circle, and wherever they meet, that point, if we draw a line that goes across to the center, it will bisect this line, and yeah. So we can geometrically it should it's actually sound for us to make that to have that assertion, right? So how are we going to find the x coordinate? Because we need that, and that's what's going to help us now find the height of the triangle. As I so if I draw a line that goes from Q, say, or from P, but let me use Q to the center, we know that this is going to be a right angle. And if I say the point of intersection here, let's just call it maybe T. We know that the gradient of TQ times the gradient of the point, this is the center of the circle, right? Let's just call it, they tell us what to use for the center. We don't know, let's just call that C. And the gradient of CT should be equal to -1 because those two are perpendicular. So I'll just say here, to find the gradient of TQ, -5 minus 1, and that's over, okay. All right, and that's over A minus 2, which becomes A plus 2, times the gradient of CT. The gradient of CT should be, or maybe just, oh yeah, let's just do that so that we avoid confusion. So the gradient of CT is going to be -5 minus 1, and that's over 3 minus 2, which is plus 2. So this should give us -1, right? So we are saying that -6 over A plus 2 is the same as, if we take this, becomes negative reciprocal, right? So it becomes 3 plus 2 is a 5, and -5 -5 minus 1 is -6, but there's a minus, so this is just like 5/6 because of this minus. Right, so 5/6 is what we get. So -6 over A plus 2 is equal to 5/6. Then we can cross multiply. So that's 5A plus 10 is equal to -36. So 5A is equal to -46. So A is equal to -46 over 5. So that is the value of A. So we now have the value of A, so everything is good. So when we have the value of A, we can now find the area of the triangle. So we're now saying the area required of the triangle. Okay, how much space have we got? I think we're good. Is equal to half times the base of the circle. I'm going to take this to be the base of the circle, this line from -11 all the way up to 1. So those are 12 units, right? From -11 to 1, so times 12 times the perpendicular height of the triangle from here to here. All right, that's the perpendicular height of the triangle. And to find that, we're simply going to say, since we know the coordinate of A, right? We got A to be -46 over 5. Sorry. So we got here to be -46 over 5. And what else do we know? We know that from the center, okay, this point here corresponds to -2. Okay, so between these 2 points, we can simply say that the distance between those 2 points is like -2 minus this. So that's like -2 plus 46. So let me write that properly. So it's just as good as -2 minus, which becomes plus 46 over 5. That's the height of the perpendicular height of the triangle. All right. So we can just do the calculation here. And what's that gonna give us? 0.5 times 12 times whatever the -2 plus 46 over 5. And whoa, whatever that will give us. That's like 216 over 5. That's 43.2. So the area comes out as 43.2. So this is the answer. That's the area of the triangle. Now, there are many different ways of solving this. This is just one. This is my way of working it out. And my method was mainly based on the geometry of the circle. You really have to understand the geometry of the circle, you know, for problems like these, for you not to struggle with problems like these ones. So I mainly base my working on taking advantage of the geometry of a circle, tangents, angle between the tangent and the radius is right angle, perpendicular lines. Those things can be quite useful when solving problems like these. Right. I hope you understood this, guys. Any questions? Maybe a part you did not quite get from what I did? Okay, silence means one of two things. People did not get a thing, or people understood what I said. But anyways, I will assume that you did understand how I did this, and we'll also have time for questions at the end, so it's all right. I guess we can move on. All right, let's go to question number 9. Circular measure it is. All right. So it says, it is given that the area of the triangle ABC, sorry, let me start from the verse. The diagram shows a sector ABC of a circle with center A and radius r centimeters. The angle BAC is alpha radians, where alpha ranges between 0 and a half pi. So, well, alpha is accurate. So in part A, it is given that the area of the triangle ABC is 4 square centimeters and the area of the sector ABC is 8 alpha square centimeters. Find the exact area of the shaded segment. All right. Let's make use of the information given. The area of the triangle ABC is 4. Area of a triangle is half AB sine theta. That's like half side r times r sine of the included angle. That's what should give us 4. So essentially half r squared sine alpha should be equal to 4. All right. We have also been told that the area of the sector is this. All right. Area of sector is half r squared alpha. Right? That's the one that we're being told that is equal to 8 alpha. So this leads to half r squared being equal to 8 if we divide both sides by alpha. Then r squared is equal to 16 if we multiply both sides by 2. Then r is equal to plus or minus 4, since if we do square root both sides, but we will use the positive value for it. Okay, so right. So we can find alpha using this. So therefore, since r is equal to 4, okay, it means that it's half. That's from equation, I'll call this equation 1. So from equation 1, it's half of 4 squared of sine alpha is equal to 4. Half of 4 squared is 8. Divide both sides by 8, we get sine alpha coming out as a half, and alpha is arcsine of a half. Okay, and arcsine of a half is 30 degrees, which is a sixth of pi. So that's what we have right here. So we got that r is 4 and that alpha is a sixth pi. Okay, sorry, my computer is running out of power. Let me reconnect it just a second. And okay, I think it's okay now. Should be all right. Let's continue. So this is what we got. What was it? Was I talking about? What do they want? They say we should find the exact area of the shaded segment. Now you need to know that if you can use a formula, the area of segment can be calculated half r squared of theta minus sine theta. Okay. Generally, this is the formula for area of a segment. If you want to do it the other way, you can just say area of sector minus area of triangle, right? But it's simply this. Right, did we even need to do this? Because they say that, okay, yeah, it's fine. Area of triangle we have, area of sector we have. All right, so we might not even need to use this formula, right? Because already the area of the triangle we have and the area of the sector we have, we only needed to find the value of alpha. So I'm not going to use this formula. I'm just going to say area of segment, right, is equal to area of sector minus the area of the triangle. Okay, this is the most convenient way to do it. For the area of the sector, we had 8 alpha, right? So we just say 8 of alpha, which we got to be a 6th pi, minus area of the triangle. They'd already told us that it was 4 there. So 4. So basically, we will just get 4 over 3 pi minus 4 as the answer. Okay, so I think this was the best way to go about it. Okay, so that was 9A. Let's go to B. On part B, they say it is given instead. When they say it is given instead, it means that what we used in part A, well, no longer holds. What holds now is this condition that it is given instead that the length of the chord BC is half R. This color seems a bit deep for me. Let me use my usual yellow. All right, so the new condition is that the length of the chord BC is 1 over root 2 R centimeters. Chord BC is this line here. So we're being told that the length of the line is 1 over root 2 of R. Okay, 1 over root 2 of R. Okay. So let me put R here, sorry. But the area of the triangle is still 4. Area of the triangle is still 4. So area of the triangle is still 4. So what do they say? They say we should find the area of the segment. We should find the area of the segment. Okay, let's go about it. So what we need to find here, all right, is the value of alpha and the new value of R, because we have new conditions here. All right. We know, okay, let's start with this fact that BC is half R, and I'm going to use the cosine rule. The cosine rule here would say half R 1 over root 2 R squared should be equal to R squared plus R squared plus 2RR, which is 2R squared, cosine of alpha. So that's like the cosine rule of trying to find half the side BC. All right. And this is as good as 1 over 2R squared is equal to 2R squared plus 2R squared cosine of alpha, right? And this is as good as half R squared of 2R squared of 1 plus cosine of alpha. Now the R squareds are going to cancel out, right? So we no longer have the R squareds, and we will divide both sides by 2, which will lead us to having 1 plus cosine of alpha is equal to a quarter, and therefore cosine of alpha is going to be a quarter minus 1, which should give us, all right, if we look at my cosine rule, I think it has to be minus, right? Because cosine rule says c squared is equal to a squared plus b squared minus, not plus, 2ab cosine of alpha. So it has to be minus here. It has to be minus here. And it has to be minus here, so that everything is well in order. I think this is a much better way of expressing our cosine rule. All right, so that cosine alpha here will be 1 minus a quarter, that's 3/4. All right, so this is what we have for cosine alpha. I'm going to take this piece of working and place it down here. Okay, I think this should be all right. So we know that cosine alpha is 3/4. All right, and therefore alpha is arc cosine of 3/4. All right. Now, I'm gonna do this because we will need sine alpha. So I'm gonna do it this way. Cosine of alpha is 3/4. So if this is like alpha, cosine is adjacent over hypotenuse. If we use Pythagoras theorem, we can find this side. That's like the square root of 4 squared minus 3 squared, right? Square root of 16 minus 9, 6 minus 9 is 7. So this is like root 7 using Pythagoras theorem. So this is like a root 7 that we have on the other side. And this is going to help us now when we use this fact. Okay, so we have fulfilled the fact that the length of BC is equal to this. We have made use of that. Now the area of the triangle is still 4. Now area of the triangle is, we said, half AB, which is RR, half AB sine theta, which is sine alpha, and they say it's still 4. Okay, and this is as good as r squared of half of sine alpha. Sine alpha, okay, to avoid confusion, this is as good as a half times r squared times sine alpha. Sine is opposite over hypotenuse here, so root 7 over 4. Root 7 over 4 is equal to 4. All right, so what's that gonna give us? So that's gonna be r squared is equal to, now this is root 7 over 8, so this is gonna be 4 times 8 over root 7. So r squared will be 32 over root 7. All right, let me write it down here. So we get in r squared to be 32 over root 7, like this. So that's what we get for r squared. Now, I think everything is now okay. And now, what do they want? They say we should find the area of the shaded segment. So we can say, like I said, the area of segment can be found by the formula half r squared, right, of theta minus sine theta. In our case, it's not theta, but it's rather alpha. So in this case, I'll just say alpha minus sine alpha. So that's going to be a half times r squared. R squared is this. So that's like 32 over root 7, right? And then that's alpha. Alpha is what we got here. That's arc cos of 3/4. All right. So I'll just use that for alpha. Arc cosine of 3/4. And that's minus sine alpha. Sine alpha is opposite over hypotenuse. So that's root 7 over 4. Root 7 over 4. So minus root 7 over 4. Right, so let's do the calculation. Okay, I think everything is now in place. All right, so we know that this is going to be, okay, let me just use my calculator so that everything is quick and fast and we get everything in place. Okay, so that's going to be half of, so that's going to be 16 over root 7, and that's going to be off arc cosine of 3/4, that's 0.75, whatever that is. Need to make sure that everything, okay, it's fine. Then that's going to be minus root 7. Let me make it a fraction first. So root 7 on top, and that's over 4. All right, and what do we get? I'm getting this. Okay, we have to be in radians, sorry. Okay, and it's now giving me 0.371. Okay, I think if I'm do it in radians, I should get a much better answer. I'm comparing it with what we got right on above. It was a small figure, 4/3 pi minus 4. And if we do it in radians, I think we should be good, 0.371. Should be a much better result. All right, what do you think, guys, for what I did? Did you get what I did? Any questions or contributions?
It looks good, sir.
Yes, sir.
Right.
I think it's good.
It's okay.
Okay. Okay, let's move on. Now we're on question 10 and we only have a few minutes to go. So let's just do number 10, the last one. So it says the function f and g are defined by f of x is equal to root x and g of x is equal to that. Describe fully a sequence of transformations which transforms the graph of f of x onto g of x, and you should make clear the order in which the transformations are applied. All right, so from f of x, we are transforming f of x to g of x, right? All right, so we can say that g of x is like 3 of f of x plus 2 minus 5. Is essentially a series of transformations that can be written in function notation like this, because f of x plus 2 is this, times 3 is this 3 minus 5 minus 5. All right, so essentially, we can say that the transformations that are going on are like this. If we start from the inside, that's the translation. This is a translation of -2 and 0. Then if we come here, then that's a stretch. And that's a stretch of vector 3 and parallel to the y-axis. And then the -5 is again a translation. So we've got two translations. And that's of here that was going to be 0 and -5 because it's a vertical translation. So we're going to combine this two into one. All right. So the more logical way to do that would be to say our first transformation, therefore, we just take the stretch independently. So the stretch of vector 3 parallel to the x to the y-axis by vector 3. All right. And for these two combined, we'll say that that's a translation of -2 and -5. So we will just take this for our result. So you can either put it this way, you can separate the translations, or you can write them as a single translation matrix. So let's just put it combined as being this. So it's a stretch of vector 3 parallel to the y-axis and translation of -2 and 5. Let's go to part B. Part B says the diagram shows the graph of y is equal to g of x. On the diagram, sketch the graph of y is equal to g inverse of x together with any relevant mirror line. Right, we know that the graph of a function and its inverse are mirror images of each other in the line y is equal to x. So if I draw the line y is equal to x like this, that should be the mirror line. Try to make it a proper line y is equal to x. So this should be the mirror line y is equal to x. So we can now draw the reflected graph, which will come on the other side, and try to make it. Okay, so yeah, I think I've done a good first attempt. So that's the graph of g inverse of x. So it will just be like that. All right, I think that should be all. Part C says we should find g inverse of x. All right, so y is equal to the original g of x is 3 root x plus 2 minus 5. Okay, so that's like 3 of root x plus 2 minus 5. So we will say that x is equal to 3 of the square root of y plus 2 minus 5. So to make y the subject, we'll be having x plus 5. Then we will divide by 3. Then we will square both sides. And then we will subtract 2. All right. So therefore, g inverse of x should be equal to x plus 5 over 3 squared minus 2. So x plus 5 squared all over 3 minus 2. So that's g inverse of x that we'll be having. Then for D, state the range of g inverse. All right. So basically, if we have a function g, okay, and we have, that's the function g, and we have its domain and range of g, then the domain of g inverse and the range of g inverse. If they want these two are the same, right? So essentially, if we want, according to what they are saying, the range of g inverse, we just look at the domain of g. The domain of g is, remember g is this function, is that x is greater than or equal to -2. So the range should also take the same form. It will be y is greater than or equal to -2. So -2. So that is the range of g inverse. And then on part C, it says the function h is defined by that. Find the value of g inverse of h of 4. So h of 4 is like 4 minus 2, which is 2. So when we say g inverse of h of 4 is as good as we're saying g inverse of 2, because h of 4 is 2, okay? And g inverse of 2, remember g inverse, we got it to be this. That was g inverse of x. Copy. Let's place it here. And there we go. In place of x, we are simply putting 2. So I'll remove this and place a 2. So that's like 7 over 3 squared minus 2, right? And that's going to give us here 7 over 3 squared minus 2, and we get 31 over 9. So that's the result we get right here. And we go to the last part, and that's F. Excuse me. So they say here, explain why the composite function h of G inverse cannot be formed. All right, so for this to be formed, right, the range of G inverse, okay, whatever it is, the range of G inverse must be, but in this case they say cannot be formed, I'll put a not. So for this to be formed, the range of G must lie within the domain of H. All right. So if these two, if HG inverse of X cannot be formed, it means that the range of G inverse does not lie or must not lie within the domain of H. Is this true? Okay. If we look at the range of G inverse, okay, remember we had G inverse of X and we got it. Now the range of G inverse must, okay, if I take you back here, the range of G inverse is like the domain of G, and it's like it is greater than or equal to -2. All right. So if we look at X being greater than or equal to -2, and then we look at that is actually the range, but we will use its Y value instead. Does it lie within the domain of H? The domain of H is here. The domain of H are values that are greater than or equal to 0. So we can say that this is not or does not lie. So it is not within the domain of H, which is values of X that are greater than or equal to 0. So values that are greater than -2 go beyond, because if you see greater than or equal to 2 cannot lie in greater than or equal to 0, because there are values that are within this that are out of this. Think of values like -2, -1 actually are not in this range of values from greater than or equal to 0. So for that reason, we can say that the composite function cannot be formed. So that's how we can answer that question. If you can give a reasonable explanation, then you'll be all right. And that, my friends, is the end of this paper. That's the end of the paper that we had